Okay, good morning to all of you. In this lecture, we are going to discuss about uniqueness theorem. Okay, in our previous class, we have been discussed in detail about existence theorem and its corresponding numericals. This one we have been discussed in detail, and another example also we have been discussed. This one also we have been discussed in detail. And we have to discuss today in this class uniqueness theorem. Okay, so let's start. So this theorem states that the initial value problem has a unique solution for all x in the interval x minus x0 less than k, where k is equal to minimum of a and b by m if fxy satisfy these two conditions. Okay, so these are the two conditions. Okay, but before we have to discuss these two conditions, I'm going to just recall whatever we have been discussed in your existence theorem. Here you can see that according to existence theorem, fxy be a continuous function in the rectangle, this one having the range of the rectangle x minus x0 less than a, y minus y0 less than b, where a and b both are positive values, and fxy mod will be less than equal to a value which is the maximum of fxy. Then the initial value problem, this one has at least one solution for all values of x in the interval x minus x0 less than k, where k is the minimum of a and b by m. So here if you are going to be read these two lines are equal to this one. You can see this theorem states that means uniqueness theorem states that the initial value problem has a unique solution for all values of x in the interval this one, where k is this one. So again, if we are going to recheck the existence theorem here, if this condition has been satisfied, then this initial value problem has at least one solution for all values of x in the interval x minus x0 less than k. Here you can see the initial value problem has a unique solution. So according to uniqueness theorem, the initial value problem has a exist, that means true. That means the initial value problem exists one single solution. But here existence theorem only told that if these conditions are satisfied, then initial value problem has at least one solution. Here by this theorem we could not confirm that it has how many solutions. It may have more than one solution, but according to existence theorem we just confirmed that for all values of x we can get one solution, at least one solution it will be possible. But uniqueness theorem will be give the confirmation regarding existence of a unique solution, or we can write uh, has a single solution. Instead of unique we can write single solution also. Okay, also we can write. So here the uniqueness theorem will be provide the confirmation of existence of single solution, right? The existence of single solution will be confirmed. Existence of single solution or unique solution will be confirmed uh, confirmed confirmed by uniqueness theorem. But by existence theorem only we can get the idea that the initial value problem has any solution or not. Okay. Now the two conditions are fxy for the uniqueness theorem. Okay, for uniqueness theorem the two conditions are fxy is continuous at all points in the closed rectangular region, that means x minus x0 less than equal to a, y minus y0 less than equal to b, and fxy mod will be less than equal to m, where you just write over here, m is the maximum of this one, m is the maximum of fxy. Okay, so here you can see that the first condition is nothing but the so-called existence theorem. This first condition itself the existence theorem, this one, EXI existence theorem. Okay, the first condition, because here you can see that if I am going to compare the first condition with existence theorem, both are equal. Here you can see the fxy should be continuous in this rectangle, and where m is your greater than equal to fxy mod, and it has at least one solution in the interval this, where k is equal to minimum of this. So the first condition is nothing but your existence theorem, right? The second condition, that fxy satisfy fxy2 minus fxy1 less than equal to L into y2 minus y1 mod. That means second condition means this one has to be satisfied by this function, and this condition also called as Lipschitz condition. Okay, this condition also called as Lipschitz condition, and this L is called as Lipschitz constant. Here xy1 and xy2 is the element of real number, and y2 minus y1, here y2 minus y1 we are going to consider very closely. That means y2 minus y1 mod is less than equal to epsilon. That means if we are going to consider y2 equal to 5, then y1 is equal to 4.9999 like this. So y2 minus y1, that means 5 minus 4.99 is very small, or it can be written as less than equal to epsilon, that one. Okay, so here y2 and y1 two values we are going to consider very closely. That means we can say y2 is approximately y1, right? Here epsilon is very small. Very small means tends to 0. So obviously y2 is approximately equal to y1. This is also called as Lipschitz condition, whatever I told. So this is the second condition that has to be followed by this function, or we can say that f x y2 minus f x y1 divided by this factor by y2 minus y1 less than equal to L. Or if here you can see y2 minus y1 is nothing but equal to 0, because both are approximately same. So as epsilon tends to 0, so this denominator is tends to 0, so we can write limit epsilon tends to 0 f x y2 minus f x y1 by y2 minus y1 mod less than equal to Lipschitz constant. So this is nothing but is your first derivative of fxy, right? This is nothing but your first derivative of fxy. So here that means fxy is exist, it is a constant value. So if fxy, sorry, first derivative of fxy is exist, that means it has a value. That means if first derivative of fxy, that means del f by del y is exist and continuous, then it will be called as your second condition. Okay, see, actually the second, many books have written only this one is your second condition, many books have written this one is your second condition, many books have been written that first derivative of fxy with respect to y, if this one exists and continuous, then we can say the uniqueness theorem has been satisfied, because already first condition has been satisfied. Second condition, may we can consider this one, may we can consider this one, or may we can consider this one. But you can, if you are going to observe carefully, both the three, all the three are same concept, same physical meaning. You can see mod of this one less than equal to L into y2 minus y1, where y2 is approximately y1, that means the differentiation will be less than, sorry, approximately 0. y2 minus y1 tends to 0 because y2 is approximately y1. And if I am going to take this term to the denominator of this term, then I can write this one itself. Here if y2 is approximately equal to y1, that means this is tends to 0. So here I can write limit epsilon tends to 0. That means epsilon value is equal to this much value, because as I told y2 approximately y1, that means y2 minus y1 is nothing but less than equal to epsilon, where epsilon is tends to 0. Or you can say both the two values are approximate with each other. If it is so, this is nothing but limit, may you have been remember whatever you have been studied in your plus 2, limit x tends to 0 f x2 minus f x1 by x2 minus x1 is nothing but del f by del x, first derivative of this function, which is the function of x, right? But here the function is the function of xy, and here you can see the function fxy, here f x y2 minus f x y1 by y2 minus y1. So obviously this can be written as in this format del f xy by del y. So here the second condition has three forms, either you can consider this one or this one or this one. If one of them, see, either one you can consider, either you have to consider this one, this one, this one. Okay, either one, if it is satisfied, that means second condition has been satisfied. So if both this 1 and 2 condition has been satisfied, then we can say uniqueness, existence of a unique solution of a initial value problem. Okay, so as I told, the first condition is belongs to your existence theorem. Second condition, for the second condition, either you can consider this expression, or you can consider this expression, or you can consider this expression. If both I and 2i are satisfied, then we can say that the initial value problem has a unique solution for all value of x. Okay, this is the confirmation that the initial value problem has a single or unique solution. Okay, now we are going to move for numericals. If we are then you are going to be clear whatever we have been discussed theoretically, right? This is the first question, and this question already we are done when we have been discussed existence theorem. Okay, here what we discussed, that uniqueness theorem has to be satisfied two conditions. One is your existence theorem, first condition is nothing but existence theorem, and second condition is your Lipschitz condition. Okay, so first condition is nothing but your existence theorem. So existence theorem, whenever we have been discussed in our last class, this example we have been discussed. Now we are going to consider this example and we are going to be discuss about its uniqueness, right? Already here we have been derived its existence. Now we are going to find out its uniqueness, right? So this is the question. For this question we have been investigated the existence of solution, and we found the solution exists for all x in the interval x mod less than 1 by 2. That means your first condition has been satisfied. This first condition has been satisfied. That means up to this much we have been discussed. Now we are going to go for second condition, that is your uniqueness. For the uniqueness theorem, or to justify the uniqueness theorem, first condition work over. Now we are going to go for the second condition, that is your Lipschitz condition. This one, or you can consider this expression, or you can consider this expression. So here given fxy is nothing but y, and now if we are going to consider fxy2 minus fxy1, it will be in the form of less than some constant y2 minus y1, right? The above equation satisfy Lipschitz condition when L equal to 1. Okay, because here you can see that fxy is nothing but your y. So, or the function fxy is nothing but y. So function xy2 minus fxy1 mod less than equal to this value. For fxy2 the value will be y2, for fxy1 the value will be y1, so y2 minus y1 mod. So this value is less than equal to this one. So here you can consider 1 into this much. So according to second condition, that means this minus this has to be less than equal to some constant into y2 minus y1 mod. So here we found that the same. This one less than equal to some constant, that is your 1, y2 minus y1 mod. So the above equation satisfy the Lipschitz condition when L, here L is equivalent to what? Is your Lipschitz constant, right? So if we are going to consider L equal to 1, that means Lipschitz condition constant Lipschitz constant will be equal to 1, then this expression is satisfied or equivalent to this expression, right? That means we can say the second condition has been satisfied, or the so-called Lipschitz condition has been satisfied, right? So therefore we can say for a initial value problem, that means for this initial value problem, a unique solution exists. That means a single solution exists in the interval x mod less than 1 by 2 of the given initial value problem. That means for given this problem there exists, that means it is given you, or it is this confirmed us that for this initial value problem one unique solution has been exist in the interval x mod less than 1 by 2. But only existence theorem only given the idea that the solution exists for all value of x, but according to this condition or according to the existence theorem, it is not confirmed that single solution exists, right? But by confirmation through the second condition, we have been confirmed that a single or unique solution is existed in the interval x mod less than 1 by 2, right? Or the second condition can be proved in this way, that one del f by del y should be exist and continuous. Here you can see fxy is how much? Y. Now first derivative of this one will be 1. That means one constant, or it is exist and its value is constant, continuous itself. So unique solution exists. So either you can for the second condition, either you can consider this one or you can consider this one. Okay, for this numerical. Here I am going to suggest one of you that suggest one thing, that suppose this question has been asked in your exam. Here I have been written this one because already this derivation we have been discussed here. But for your exam, you have to derive this one up to this much. That means you have to prove the existence theorem. That means first condition you have to prove. That means up to this much. From here to here with this figure you have to write. Then you have to consider the second condition and you have to write either this one or this one. Okay, as we have been discussed previously, so I written this much, but for your exam you have to write these things. Okay, now we are going to go for the second question. This second question also we have been discussed whenever we have discussing the existence theorem, this one. Okay, y dash equal to x square plus y square, y0 equal to 0, and we saw at that time that for this existence for this initial value problem, there exists a solution in the interval x mod 1 by 2a. Already we have been discussed. So if this question is asked in your exam, first you have to derive this much. Okay, you have to derive this much and you have to write up to this much. Then you are going to go for the second condition. Second condition means if we are going to consider this one, it will be in the form of some constant into y2 minus y1. Let's check it out. So here it is given that the function is your x square plus y square, x square plus y square. Now fxy2 minus fxy1 will be how much? Here x is not going to be changed. Instead of y we have to put y2 square, because here y square means y2 square minus fxy1. That means x square is x square, y will be y1 square, right? So if I am going to take the mod, so this will be obviously less than equal to x square plus y square minus x square plus y2 square minus x square plus y1 square whole mod. So here you can see this will be minus x square and minus y1 square. The minus and plus got cancel. The mod we can found this will be less than equal to y2 square minus y1 square whole mod. Here this is the form of a square minus b square. We can write a plus b into a minus b format. So y2 plus y1 into y2 minus y1 whole mod. So here you can see y2 and y1 both are real values, right? Whatever we have been discussed here, you can see here as I told that xy1 and xy2 both are real values. Means you can consider real value means maybe fraction or maybe integer. Suppose maybe it will be 3 or maybe it will be 1.3, like this. Okay, some real value, or maybe minus we can consider. So if it is so, if it is the real value, then if I am going to add these two values, so it will give some value, right? And after all, if we are going to consider the y2 and y1 value, what we are going to get? You can see that here in this question there is no range has been given. So may you have been remember, if range has been not given means y will be considered as less than equal to b, right? Some constant y mod less than equal to b we have to consider. x mod less than equal to a we have to consider to draw the rectangle. Okay, so here y value is less than equal to b. So now here if we are going to consider the maximum value of y itself, then this will be b and this will be b, because y minus 0 less than equal to b, that means the maximum value of y will be b. So then y2 if I am going to consider b and y1 if I am going to consider b, then the value will be 2b into y2 minus y1. Okay, or as I told that this y2 y1 x, these are the real values. So this will be, after adding this one y2 minus y1, it will be a real value, or we can write some constant, right? So some constant, we can found some constant into y2 minus y1. So here at last what we found, fx y2 minus fx y1 fx y1 mod less than equal to some constant. So here you can write 2b or you can write c itself, no problem, because as we saw that both y2 and y1 are the real values, so you can write here 2b or you can write c itself, some constant. Here I considered the maximum value of y, so only for that I have been written 2b, right? Now if I am going to compare this expression with the Lipschitz condition, here this one is your Lipschitz condition, both are identical. So here this minus this x y2 x y1 less than equal to some constant y2 minus y1. So here also we got the same, fx y2 minus fx y1 less than equal to some constant y2 minus y1. That means this satisfied the Lipschitz condition. Therefore we can say, here we can say, I not written, but that meaning is the same, that therefore there exists a unique, a single, that means a single solution or unique solution of the given initial value problem in the interval x mod less than equal to 2a. So as I told that if this question has been asked, first you have to derive its existence. Existenceness you have to derive up to this much. Up to this much you have to derive. Then you have to go for the second condition and you have to write up to this much. Okay. So by first condition we confirmed that this initial value problem has some solution. That means at least one solution exists for all value of x in the interval x mod less than equal to a. And by considering second condition, that is your Lipschitz condition, we have been confirmed that this initial value problem has unique solution, single solution in the interval x mod less than equal to 1 by 2a. Or we can consider another way about the second condition. As I told that we have to consider the first derivative with respect to y of fxy. Here fxy is given that x square plus y square. Now if we are going to consider the first derivative with respect to y, then we are going to get how much? 2y. 2y is nothing but continuous for all values of y. So that it is unique solution in the interval x mod less than equal to 2a. So for again I am suggesting that if this question will be asked in your exam, first you have to evaluate these things. That means first condition whatever we have been written here. See here I written only for that, I not written once again over here, only here I written these 3 and 4 lines, but in your exam you have to write this one, you have to write this much up to this much. Okay, then second condition, and for the second condition either you have to follow this one or you have to write this one, no problem. This is your Lipschitz condition, this is itself the Lipschitz condition, but in the another form. That means first derivative should be continuous. First derivative we found the continuous 2y, so it has unique solution in the interval this one. So in your exam, this derivation you have to write, and for the second condition either you have to write this much, okay, this much you have to write, or for the second condition I am telling, for the second condition either you have to write this much or you have to write this much up to these two lines, no problem. Okay, now you are going to be confused that this much, if we are not going to write, our mark will be reduced. No, same, whatever the derivation here, it is the same, the first derivative itself. Okay, for again and again I am telling, the second condition you can either you have to write this much or this much. Now we are going to go for the next question, that is a study the existence and uniqueness of the initial value problem, that is your y dash equal to x y square initial value problem, y0 equal to 0, where the region x mod less than equal to 1, y mod less than equal to 1. So this is the first question, new question. First we have to consider its existence, that means first condition, existence means first condition, then we are going to go for the second condition, right, or the so called Lipschitz condition. So this is existence means is the first condition, right. So here given fxy equal to xy square, that means we are going to go for the existence theorem, the same procedure whatever we have been discussed in our last class, same procedure I am following here, and I suggest that you all have to write in this procedure. May you are going to be skip some steps in your exam, but in the note you have to write down step by step clearly, that you can, whenever you are going to be study further after some days, you can understand easily, right. So given here, given fxy equal to xy square, and initial value problem means y0 equal to 0, that means x0 is your 0, so y0 is, this value is 0. The range is nothing but x mod less than equal to 1, that means -1 to 1, the range will be -1 to 1. How it will be, last class we have been discussed in detail with the example, and y mod has been given less than 1, that means y will be -1 to 1, y range will be -1 to 1. By considering two ranges, we can draw this rectangle. Here x will be -1 to 1, y will be -1 to 1. So this line is nothing but x equal to -1, this line is nothing but x equal to 1, this line is nothing but x equal to -1, this line y equal to -1, this line will be y equal to 1. So as both the values are same, so this rectangle is nothing but a square, no problem. So this, in this rectangle, this function is continuous, right. So the maximum value of a and b are nothing but 1 and 1. So a and b means this value is your a and this value of is your b. Just recall, whenever we are discussing the existence theorem, this range x minus x0 less than equal to a, y minus y0 less than equal to b. So this is a, this is your b. So here you can see x minus x0 less than equal to 1. So here this is nothing but a, okay, this is equal to b. So a and b value are 1 and 1, 1 and 1. So maximum value of fxy, obviously how much? Here I am going to put 1, 1, 1, 1 square, itself 1, 1, that is your m, right. So k is nothing but minimum value of a and b by m. A is what? A is value is 1 and b is your 1, m is also 1, b by m also 1. So k value is nothing but 1 itself, right. So here we can say that solution exists. That means for this initial value problem, solution exists for all value of x in between -8 1 to 1. That means from -1 to 1, for all value of x, solution exists. Okay, or we can write at least okay, at least one solution exists, because according to existence theorem, what we have to write at least one solution. Okay, so here you can write at least one solution exists for all values of x in the interval x less than equal to 1. But by uniqueness theorem we have to prove that it has, this initial value problem has unique solution or not, right? So for uniqueness theorem, or to justify the uniqueness theorem, we have to check the satisfy that this condition and this condition. Already first condition has been satisfied, whatever we have been discussed, and second condition is your Lipschitz condition that we are going to be checked. Okay, so for this case fxy equal to xy square is given. Now we have to consider Lipschitz condition. Lipschitz condition means fxy2 minus fxy1 mod we have to consider. That means this should be less than equal to some constant y2 minus y1. Okay, now we are going to be check here. fxy2 minus fxy1 will be equal to, here fxy is your xy square, so xy2 square minus xy1 square. Then it will be obviously this value equal to this much, so this value obviously less than equal to mod of this one. So taken x as common, y2 square minus y1 square, so x as real value, so x mod taken outside, so this will be y2 minus y1 and y2 plus y1. So separately can be written as y2 plus y1 mod into y2 minus y1 mod, no problem, right? So this less than equal to, here I consider the maximum value of x. The maximum value of x is how much? 1, and maximum value is y is 1. So this will be x mod is 1 and maximum value is y is 1, and y1 y2 are both are as equal or very nearer, so we can write 1 plus 1, that means 2, y2 minus y1. So here 1 into 2 is 2, y2 minus y1, so some constant into this one. So if I am going to be compare with this equation with Lipschitz condition, this one, it is exactly matched. So this one Lipschitz condition, this one some constant less than equal to some constant y2 minus y1, so this is matched with this one. So here L is nothing but 2. Lipschitz constant for this one, for this case Lipschitz constant is your 2. So this is satisfied the Lipschitz condition where L equal to 2. L equal to 2. So what we are going to be say after this much derivation? So here first condition has been satisfied, second condition or the so-called Lipschitz condition also satisfied. So we can say that, therefore we can say there exists a unique solution. So according to existence theorem, at least one solution exists, maybe more than one solution, but as it is satisfied Lipschitz condition, so we have to confirm that, or we confirmed that this initial value problem has a unique solution. So therefore we can say there exists a unique solution of given initial value problem in the interval x mod less than equal to 1, right? This can be verified by considering another form of Lipschitz condition, that is your first derivative of fxy should be continuous, that we have to check. So del by del y of this one xy square will be 2xy. This is nothing but for, that means for all x and y value, this value is continuous everywhere in this interval, in this region. So as it is continuous and it is exists, its first derivative exists and it is continuous, so it has uniqueness solution in the interval this one. That means, see, this sentence you have to write after by deriving the Lipschitz condition or by considering this way. Okay, so here I am suggest that the second condition, the so-called Lipschitz condition, you can write up in your exam. I am telling, up to this much you can write. Okay, then you have to write this sentence or only this much you have to write, and you have to write this derivative or the first derivative is exist and continuous, so that therefore this you can write, no problem. But I suggest that in two way you have to write in your note, but your exam may you can write this one, because this one by one step or within two steps or only one step we just prove that this first derivative exists and it is continuous. So hence, therefore, we can say there exists a unique solution of given initial value problem in interval x mod less than equal to 1. Okay. Now we are going to go for the next question, that we have to discuss the existence and uniqueness theorem, uniqueness of the solution of the initial value problem y dash equal to y to the power 2 by 3 y0 equal to 0. First we have to consider the first one, that means existence condition, existence theorem, or the so called first condition that we have to check. So here y dash is given as y to the power 2 by 3, or fxy is nothing but y to the power 2 by 3, right? But here for the rectangle there is no given the range. Okay, and initial value problem means it is given the initial value condition, that means y0 equal to 0, that means x0, this is x0 equal to this is y0. So x0 equal to 0, y0 equal to 0. As the range of the rectangle not given, so we can consider x mod less than equal to a and y mod less than equal to b. So here x0 equal to 0, that means we can write x minus 0 less than equal to a, y minus 0 less than equal to b. That means x0 y0 both are at center origin, and the x rectangle x range is your minus a to plus a, and y range is your minus b to plus b. Okay, and the maximum value of fxy is your m equal to how much? Here if I am going to consider the maximum value of y, here maximum value of y is b, so here b to the power 2 by 3. So the minimum value in between a and b by m, so k is nothing but minimum of a and b by m, b by b to the power 2 by 3, so this will be b to the power 1 by 3. So here you can see that this is a and this is your 1 by b to the power something, so obviously this value will be less than that of the a. So k value is your 1 by b to the power 1 by 3. So we can say that the solution exists for all x in the interval x mod less than 1 by b to the power 1 by 3. Now we are going to consider the Lipschitz condition. Lipschitz condition, to verify Lipschitz condition, that means we have to consider fx y2 minus fx yx y1 is equal to how much? This will be y2 to the power 2 by 3 minus y1 to the power 2 by 3. Here you can see the right hand side is not in the form of y2 minus y1. So for this initial value problem, Lipschitz condition not to be applicable to obtain the uniqueness of the solution. So for this question you have to write up to this much, and for the uniqueness that means Lipschitz condition could not be applicable to find out to justify the uniqueness of the solution, right? Now we are going to go for the next question, that is study the existence and uniqueness of the initial value problem. This one y0 equal to 0, x range of the region is given by x less than x mod less than equal to 2, y mod less than equal to 1. So here y dash, that means fxy is given this one. So initial value condition is this one, that means x0 equal to 0, y0 equal to 0, and the rectangular region, that means x mod is your less than equal to 2, and here x0 equal to how much? 0, y0 equal to 0, that means x0 y0 both will be at center, and the range of the x will be minus 2 to 2, y will be minus 1 to 1. So this will be minus 2 to 2, x range, y range is your minus 1 to 1, and this line is nothing but y equal to 1. This line is your y equal to minus 1. This line x equal to 1, x equal to minus 1. So this region enclosed by these four lines, here it is represented. The maximum value of fxy, that is your m, is nothing but, we have to consider here 1 plus 2 x. X maximum value is how much? 2. Y maximum value is how much? Is your 1. That maximum values we have to substitute. So 1 plus 2, 2 into 2 will be 4. So 3 into 1 will be 3. Then in the denominator 2 plus 2 square plus 1 square, 4 plus 1 will be 8 by 7. So now we have to consider k is the minimum between a and b by m. So here b maximum is 1, by m is nothing but 8 by 7. So 2 and 7 by 8. So among 2 and 7 by 8, the minimum value is 7 by 8. So we can say that the existence, the solution at least, that means at least one solution exists for all x in interval x mod less than equal to 7 by 8. Okay, now we are going to go for the uniqueness theorem to find out it has unique solution or not. That we have to consider the Lipschitz condition. So for the Lipschitz condition, we have to consider this one, fxy2 minus fxy1. So here fxy is nothing but this one. So first we have to consider y2, then minus y1. So it will be 1 plus 2x plus y2 by 2 plus x square plus y2 square minus 1 plus 2x plus y1 by 1 plus x square plus y1 square, right? Now so this will be mod will be equal to, first we have to just simplify. So here you can see this minus this, right? So now here we are going to put the maximum value of x. Okay, so maximum value of x, if I am going to put, then it will be 1 plus 4 plus y2 by 2 plus 4 plus y2 square minus 1 plus 4 plus y2 y1 by 1 2 plus 4 plus y1 square. Then further simplify, we can get this one. See, this will be 5 plus y2 by 6 plus y2 square. This will be 5 plus y1 by 6 plus y2 square. Then if I am going to be subtract, then we are going to get this much value. So mod of this is equal to this much. So mod of this will be less than equal to this much. Okay, I forgot to write less than equal to this much, right? See, here you can see that if I am going to see this value, numerator value divided by this one equal to this much. If I am going to remove the denominator, so obviously this value will be greater than this one. See, 2 by 3 is there. If I will remove the denominator, only we can get 2, obviously greater than that of the 2 by 3. Okay, likewise here this much value is there. If I am going to remove this denominator, I am going to consider this one. Obviously this value is greater than that of the value this one, which will equal to this value. So obviously this value will be greater than equal to this value, right? So so greater than equal to, I am just multiplied, nothing else, multiplied and further simplifying. Further you just put the mod. Further simplification, you just check the steps and write down in your note. So here you come to this step. Here y2 minus y1, y2 minus y1, y2 square minus y1 square can be taken as. That means y2 minus y1 can be taken common from this. y2 minus y1 into this much mod. So but we know that y2 approximately y1. So we can write that this value will be uh, this value is with 2y1, sorry, this will be y2 plus y2, that means 2y2. So 2 into 5 equal to 10, 10y2 plus 6 minus y2, here y2 minus y1 is there, just put the mod. So here it, as I told that both x and y values are your real values, so this will be a constant value. That means if I am going to put the maximum value of y2, whatever I am going to get, maximum value of y2 is how much? Here you can see maximum value is 1. So here how much you can get? So this will be minus 10 plus 6 minus 1. So this will be minus 11 plus 6 will be minus 5. So minus 5 will be act as your Lipschitz constant. So here this value, this mod is less than equal to y2 minus y1 into this L value. This L value is nothing but minus 5, that is your Lipschitz constant, and which is satisfy the Lipschitz condition. So if it is so, then we can say, that means therefore we can say there exists a unique solution of given initial value problem, value problem in the interval x mod less than equal to 7/8. So here we just followed the Lipschitz condition in this format, but someone can be considered the first derivative of this one. This is your fxy, the first derivative, that means del f by del y will be this one. You just do it by considering the division formula, you can get this one. That means this value is valid, that means this value is exists and also continuous in this interval, that means in this region exist and continuous, so that we can say this initial value problem has unique solution in the interval this one. So again I am going to suggest that in your exam either you have to go for this one like this up to this much, or you can consider the first derivative like this up to this much you can write, no problem at all. Okay, now we are going to go for the next question only, that means this question that you have to solve, study the existence and uniqueness of the initial value problem y dash equal to x plus y square, where y0 equal to 0, that means this is your x0, this is your y0, right? Here it is not given any range, so you can consider x mod less than equal to a, y mod less than equal to b, and do by yourself and ready for the next class. So thank you so much for watching this video. I suggest to all of you that whatever we have been discussing in this video, carefully you have to watch and perfectly write down your note, because note is very essential for at the time of your exam. Okay, so thank you so much for watching this video. Thank you.